Then you had slightly more complex problems where you had to apply PEMDAS, but it was a little bit more complex because we had opportunities to use the distributive property. Now, here's an example. We have 3/4 times 4x plus 8. And we'll just keep it relatively simple now. We'll say minus 7 at the back end there. Now, as you know, there is the distributive property, so 3/4 gets distributed there, and it gets distributed there. Okay? Now, what that looks like in slow motion is 3/4, and I'm going to put it in parentheses just to keep things nice and neat, times a 4x. And then we have a positive 3/4 times an 8. And then we have the negative 7 over here. Okay. Now, this situation right here, it can be confusing for some. Now, you demonstrated earlier that you recognize that these will cancel out, but I want to make sure that you understand why that is. We're going to dissect that situation right now and bring it over here. Okay. So what we're dealing with is a 3/4 times a 4x. And in a sense, it's really 4x, but it's really 4 times x. So I'm going to separate things out with parentheses just to get very clear that this is like a string of things being multiplied together. Okay? Now, it's helpful to remember that when you're multiplying a fraction times a whole number, it's helpful to remember that every whole number secretly has a 1 underneath it. So, in a sense, you're really multiplying a fraction times a fraction. Now, when you're multiplying fractions times fractions, the rule there is to just multiply straight across. Typically, it's 3 times 4 is 12, and then 4 times 1 is just 4. So you could write 12 over 4 times x. That's fine. But before you do that multiplication straight across, it's always a good habit to get into to just analyze these two fractions that are being multiplied together and ask yourself if there's any diagonal relationships here that could represent opportunities to do a cross cancellation. Now, a cross cancellation is when you recognize that the denominator of one and the numerator of the other have a common factor that they could both be divided by. Now, 4 and 4 have a common factor of 4, a greatest common factor of 4. So that means that this 4 could be divided by 4, and this 4 could be divided by 4. 4 divides evenly into 4, and 4 divides evenly into this 4 too. So 4 divided by 4 down here would give us a 1, and 4 divided by 4 up here would give us a 1. Then you can think of it as multiplying straight across, but instead of a 3 times a 4, it's now a 3 times a 1. And instead of a 4 times a 1, it's now a 1 times a 1. So we will multiply straight across. And actually, we're going to multiply straight across. Well, I'll keep it over here for now. We're going to bring the work to this section. So this 3 times 1 would give us just a 3. And this 1 times a 1 would give us just a 1. So what we're dealing with then is a 3 over 1 times x. Now typically, when we have a 3 over 1 or any number over a 1, we don't bother with this 1 in the denominator because every number secretly has a 1 in the denominator. So this 3 over 1 times x, ultimately, it's just 3x. Okay, so the way that you wrote it, which is fine, but you kind of, in a sense, did all this quickly in your head, and you just recognize that, oh, well, this 4 cancels out with this 4, and then that leaves me with a 3 times the x. And in my opinion, that's an okay way to do it as long as you understand why you're doing it that way. So we have a 3x left over, in a sense. So it's like 3x plus whatever this ends up being. Okay, now the 3/4 times the 8, again, we could take that situation and kind of demonstrate it off to the side over here, where that ends up becoming, obviously, it's going to be 3/4 times 8. Now, we don't have an x over here, so it's just 3/4 times 8. And in a sense, the thinking process is the same. There's an invisible 1 in the denominator, and you're going to be multiplying a fraction times a fraction. Now, we could multiply straight across. That would actually work. However, to make things easier on ourselves, we're going to analyze and see if there's any diagonal relationships here where there's opportunities to do a cross cancellation. Now, there is an opportunity with the 4 and the 8, and you ask yourself, are there any common factors other than 1 that divide into 4 and into 8? Well, actually, yes. 4 divides into 4 and 4 divides into 8. So I'm going to go 4 divided by 4. What's that? Well, that ends up being just a 1. 8 divided by 4 ends up being just a 2. So instead of multiplying a 3 times an 8, I'm going to multiply a 3 times a 2. Instead of multiplying a 4 times a 1, I'm going to multiply a 1 times a 1. And that ends up being a much simpler situation where 3 times 2 is just 6, and then 1 times 1 is just a 1. And again, as stated before, we have a 1 in the denominator, so we're just going to ignore it, and we're just going to focus only on that 6 there. So that is the kind of slow motion demonstration of what's happening when you do the 3/4 times the 8. And it ends up becoming 6, as we said. So we have a 6 down below. Now the way that you did it before, which was correct, is you saw this 4 and you just turned it into a 1, and you saw this 8 and you turned it into a 2. And then you just multiplied the 3 times the 2 and you end up with a 6. Now I'm all for that. That's perfectly fine, once again, as long as you know why it works out that way. Alright, so we have 3x plus 6, and then we have minus 7. And then analyzing this expression right here, you can see that this 3x is the only term featured in this expression that has an x in it. So this 3x cannot be combined with anything. However, this 6 and the negative 7 can be combined because they don't have an x. What we call those are constants, as you probably know. So 6 minus 7 is just a negative 1, and we end up with a 3x minus 1, and that ends up being the answer.